Everybody, this video is for those who were absent on Friday, October 27th. Our objective today is I will be able to explain the rate of plate motion, and by rate I mean the speed of plate motion. We're going to start chapter 3 will be in Amplify 3.1. We're doing all activities except for the homework. Your homework is to study for vocab and key concept test, which is November 1st, and then the Amplify test on November 2nd. When you opened up this folder today, you probably saw that I have your plate motion vocabulary and key concept practice test here. Let me encourage you to put that in good notes. Use that to study for your test next week. I organized it a little bit differently, so let me kind of explain that really quickly. So first of all, it says chapter 1, and I made sure to include the title of chapter 1. I think that will help you kind of orient yourself and make sure that you remember what that chapter was about. That could help you with your key concepts especially. So all of the vocabulary terms from chapter 1 are here. And then I said there are 4 key concepts in chapter 1. Write them in the space below. So I will let you put the key concepts any way that you want to. So if you say, Earth's outer layer is made of hard solid rock, it's divided into sections called plates, and those plates move. You can just write that as a little short mini paragraph. And then that's key concepts 1, 2, and 4. And then you would just write key concept number 3 kind of separately. If you want to go ahead and number them and do 1, 2, 3, 4, because that's how you memorized them, then that's fine. Go ahead and do that. If you want to put bullets, do that. I don't care. Just your 4 key concepts need to go right here. Chapter 2 is understanding plate boundaries. So there's your vocab. That had 2 key concepts, so again, you can write those any way you want. And then chapter 3, we only had 1 new vocab term, which is rate, and there are 2 key concepts in chapter 3, so make sure that you include those in the space below. Let's go ahead and go to our lesson for today. And again, this is just a summary, so I want to go over this kind of quickly, but you're responsible for knowing this information. In the warm-up, we just talked real quickly about whether or not we could feel plate movement and start to think about how plates move and actually the rate or the speed at which plates move. And we all agreed that we can't feel the plates move, and we know that they're moving slowly, but there are a lot of different ideas about how quickly it moves. And so we're in activity 2. Our chapter 3 question is, at what rate did the Mesosaurus fossils on the South American plate and the African plate get so far apart? That grammatically, that sentence doesn't make sense. But we're just trying to find out, did it happen quickly or suddenly, or did it happen gradually? And in every class, all the kids agreed very quickly that claim number 1, we know that the plates didn't move suddenly and then kind of slow down over time. We know that they moved gradually over a long period of time. The thing is, though, we don't have any evidence for that. It's just something that we just already know innately. We did have evidence back, I think it was in chapter 1 or PB1. We had a sim where you guys were supposed to determine whether earthquakes cause plate motion or plate motion causes earthquakes. And we determined that the plates are constantly moving, and that's what causes the earthquakes to occur. And so if claim number 1 was correct, then we would expect to see a stopping and starting of plate motion, and that's not what we see. But what we don't have is any evidence to show us that it happens gradually. And so that's what we're going to do today. We're going to go into the sim. I'm going to talk about this real quick. Oh, yes. Can you please, on activity number 2, if you hit screen number 1, I believe, you're going to see this plate movement map. And we've seen this map before. This is the same plate boundary map that we used, and then we saw the black dots and the red triangles to mark earthquakes and volcanic activity. Now you see we've got all these different arrows and pointing in all different directions, and then the numbers next to them. And if you look down at the key, you realize that the arrows are showing where divergent and convergent plate boundaries are. And we even have a couple transform plate boundaries. And so if you look over here by California, we can see a transform plate boundary there. But these are divergent, these are convergent. A couple of kids were noticing if we have divergent on one end most likely you'll have convergent on the other, and that's that whole kind of, it helps us understand that whole conveyor belt idea of these plates just, sinking into the mantle and melting, and then the mantle coming up and cooling and hardening, and it's just this constant cycle of rock formation and recycling. But the one thing I want to point out is the numbers are different. And so the rate at which the plates are moving per year is different. If you look at the plate boundary between South America and Africa, you'll see that plate boundary is moving at a rate of about 3 centimeters per year. And we've got some that are moving like 1.2, 1.7, 1.8, and then some that are moving 10.1, 17.2. This one's really moving fast comparatively. But on average, plate boundaries move about 2 centimeters a year. Rate means speed. And basically the definition is it's how often or how fast something happens. It's the number of times per minute, or the number or the distance traveled per minute or per time unit. We have a formula to find rate, and that's distance divided by time. And I'm going to make sure that you know that, because you need to use that for the sim activity that we did today. Okay, I'm going to skip that. We need to get data, that's what this is saying, over a long period of time, because if we can identify some patterns of the rate of plate motion over a long period of time, then that's evidence for us, and that's what we're looking for. So I'm going to show you how to measure the sim. If you go into your, I'm trying to think how to show this to you. I'm going to do this next, sorry. Go into Activity 2, Screen 3, and you've got some directions for running a simulation. Underneath that, you have a data sheet. And I want you to understand what you're going to do here. First of all, go ahead and fill in the rest of the data table right here. In your time, yours is blank. We're going to check it every 50 million years. Okay? So go ahead and in this first row, put 50, then 100, 150, and 200. And then we're going to record the distance between two markers. And then we've got everything that we need to find rate, which is distance divided by time. So I'm trying to think about how to do this while I'm just on a video, so I'll just demonstrate it for you. So go into the sim, you're going to go into region 2. We don't need to add any plates. We don't need to thicken any of the plates into a continent, so we're just going to leave it alone. I'm going to take a marker, number 1, and I'm going to bring it over here to this plate, and we want to put it as close to the plate boundary as possible without getting it directly on the plate boundary. And then bring over marker number 2 and put it close to marker number 1 on the other plate. I'm going to set the plate boundary to divergent, so it added a little bit of a continent there. That's totally fine. And I'm going to run it, and I'm going to try and stop it at 50 million years. And so let's do this. I'll do it. You fill in the information, okay? Ooh, got it. 50 million years. So the way you find the distance is you're going to click on one of these markers. The blue dashed line right here, hang on, is showing the distance from the marker to the plate boundary. I don't want that. I'm going to click on the number, and it's going to have this straight line now to my marker number 2. And if I look in this box, I see the gray number 2 marker, and it tells me the distance is 1195, so 1,195 kilometers. And so you're going to go back here and you're going to put in 1,195. Like that. Okay? And then let's go back to Amplify, and we're going to run it for another 50 million years. So we're going to stop at 100 million years. See if I can do it. Ooh. Oh, I missed it. Okay, so anyway, that's fine. 101 is fine. So I'm going to click on my marker again, and this time it is 2,333 kilometers. So down here, I'm going to bring that down, and I'm going to change it. Whoops. To 2,333. Okay, and then come back. Let's run it again for another 50. Gosh, I get so nervous. Did it again. All right, and so now that's 3,463. 3,463. I'm writing it down on a piece of paper. And then I'll come down here, add it down here again, and hopefully you're doing this in your Amplify text box, your data box. Okay, and then lastly, let's go ahead and run it to another 50 million years, so we'll stop at 200. Maybe. Oh, it'll run out, won't it? Good. All right, so now I'm going to click on here, and my last distance was 4,550. And so I'll move that down here. 4,550. So now what I'm going to do is I've got to figure out my rate then. So I'm going to take the distance, so 1,195, and I'm going to divide that by 50. Okay, that's my time. And the answer is 23.9. I'm going to go ahead and round that up to 24. So I want you to go ahead and do the rest of those, and then we'll come back and make sure that you and I have the same one, okay? Okay, so here we are. You've got your data. I've got mine. Not really, I'm not going to lie. I'm doing this on the fly. So now I've got 2,333. Oh, that's duh. That's 23.3, so I'm going to round that down to 23. That is 23. And then the last one is 22.27, so I'm going to round that up to 23. So what does the pattern show us? The pattern shows us that over the course of 200 million years, the rate is pretty much the same. So if I go back to my original claims that the plates either moved suddenly or they moved gradually, the data we have, the pattern that I see, it definitely supports the idea that these plates moved gradually. That's all I want to talk about today. Let's talk about Earth's key concept number 8. What we're realizing is now we understand why the plates on Earth move an average of 2 centimeters per year. It's so slow. So key concept 8 says Earth's plates travel at a rate too slow to be experienced by humans. So you know those questions that you had on your test where one person is freaking out because they're afraid the continents are going to crash into each other? You can tell them, first of all, they're not going to crash into each other because they're already next to each other, next to the plate boundary. But plate motion happens at a rate too slow to be experienced by humans. It's happening right now. You don't have to worry about it. All right, that's it. Make sure that you're studying for your vocab and your key concept test on Wednesday. See ya.